In this module, we zoom into one critical moment: how a relying party asks your EUDI wallet for identity data, and how OIDC4VP delivers a secure, verifiable presentation back. Think of it as the protocol glue that links onboarding, KYC, and trust checks into one coherent flow. You've already put the foundations in place: regulation, wallet actors, KYC journeys, compliance controls, and a full onboarding architecture. Then we layered in verifiable credentials and presentations. Now we move to the relying party's perspective: how OIDC4VP requests those presentations, transports them securely, and validates what comes back. OIDC4VP is the missing protocol glue between a customer's wallet and a KYC onboarding system. It lets the verifier ask for exactly the attributes and evidence it needs in a structured way and receive a verifiable presentation in return. The user can see what's being requested, then choose to consent or decline. Where credentials support it, only the minimum necessary data is disclosed, and each response is cryptographically bound to that specific request and verifier. In OIDC4VP, think in terms of business roles and technical components. The relying party is the business application that needs verified data for onboarding or KYC. It delegates the protocol work to a verifier service, which builds the request, validates the presentation, and enforces trust policies. The wallet, controlled by the user, selects which attributes to share. Finally, a back-end KYC platform consumes those verified claims for scoring, profiling, audit, and decisions. A presentation request is essentially the question the relying party asks the wallet. Design it by starting from the decision you need to make: onboarding, KYC, or a specific risk check. Then decide which claims are truly required and which credential types, issuers, and assurance levels you'll accept. Make the purpose clear in human language and map every field back to a regulation or policy. If a data element has no clear justification, it should not be requested. Each core request parameter plays a distinct architectural role. The client ID lets the wallet decide whether it trusts this verifier at all. The redirect URI or response endpoint defines the only legitimate destination for the user's data. Nonce and state bind the response to a single, unrepeatable transaction, closing replay, and mix-up gaps. Finally, the presentation definition expresses what credentials are needed, enabling least privilege and interoperability. A presentation definition is basically the policy brain behind a verification request. It tells the wallet which credential types are acceptable, which attributes must appear, and where to find them in the credential. It can say ID card required, bank statement optional, or age must be over 18 and income above a threshold. It also encodes issuer trust and allowed formats, so different wallets and verifiers can interpret the same request consistently and avoid ambiguity. With wallet-based KYC, the key is explaining why each data element is needed, then asking for no more than that. OIDC4VP lets the relying party express purpose text that maps directly to data minimization and purpose limitation. The wallet can then show the user exactly what's being requested and why. Selective disclosure reveals only the necessary attributes, while consent and transaction records provide strong audit evidence for regulators. Once the verifier has built a presentation request, the next step is getting it into the user's wallet. For desktop users, that's usually a QR code that pushes the request to the phone. If everything happens on the same mobile device, deep links or universal links feel most natural. Browser redirects work for purely web journeys, but they require strong anti-phishing controls. And in cross-device flows, session binding is critical, so browser, wallet, and backend all agree on the same transaction. In OIDC4VP, the user journey spans browser, wallet, and back again. The verifier must clearly show who's asking, why they're asking, and what attributes will be shared. Then maintain that context when the user returns. Use short-lived, non-leaky request URLs and bind the session tightly to the transaction. Also design recovery paths. Expired QR codes, unsupported wallets, abandoned flows, and failed handoffs should always have a safe, obvious next step. When the user approves, the wallet sends back a presentation response. It contains the verifiable presentation or token, plus protocol data like metadata and a nonce, so the verifier can link it to the original request. This response must arrive only through an authorized redirect or endpoint. From there, it enters the verifier's validation pipeline as untrusted input, until signatures, audience, timestamps, issuer trust, and status all check out. The verifier's job is to turn a raw presentation into something business systems can actually trust and use. First, it correlates the response with the original request, so we know which transaction we're looking at. Next, it enforces protocol and cryptographic checks before any claims are consumed. Only after that do we extract attributes, normalize them into the canonical customer model, and feed both results and audit evidence into onboarding and KYC engines. In OIDC4VP, think about 4 protection layers. First, secure the request itself with signatures or request objects, so attackers can't modify what the verifier asks for. Second, make sure the response is really meant for your verifier by checking audience. Third, verify issuer and credential signatures. Finally, enforce nonce, state, timestamps, and expirations, so old or stolen presentations can't be replayed into active sessions. Think of OIDC4VP as a security gateway. When anything feels off, it must fail closed. An expired request or user cancellation is user correctable. Give a clear, gentle restart path. But invalid signatures, nonce mismatches, untrusted issuers, or correlation failures are security events. Don't process claims, and don't leak detailed validation results to users or verbose logs. Instead, emit structured error codes, raise audit events, and route ambiguous or high-risk cases to manual review. OIDC4VP is how verifiable presentations become a real onboarding flow. You design the request, the wallet journey across devices, and the response validation pipeline. Every step must preserve privacy, bind the transaction, and produce auditable evidence. Next, we move on to OIDC4VCI issuance, then deeper trust, status, and error handling.